The main assumptions I made for these tasks were, first of all, easy implementation and easy integration of logs into selected views. The logs should be readable by the end user who is not a technical person. And finally, recording user activity should not affect the server response time. Having such assumptions, I decided to save logs in the database. For the views, I prepared a mixin, and for the recording users activity and saving logs in database, I created dedicated Celery task. Okay, let's see the implementation details. First, the database. I decided to use database, although we can imagine some limitations associated with such a choice, especially when it comes to the size of the database, which can become quite big when saving logs. However, based on my experience, I know that this is not a very big problem. Although for very large projects with very high traffic, it is worth considering at the beginning where to store this data. In my case, if the database grows too much, I will think about splitting it into smaller chunks or at all separating this part of model into separate database, and even this does not necessarily have to be a Postgres database as it is now. If this happens, it will be a good reason to make a short video on how to perform this kind of operation. Let's go back to the model. As you can see, it's quite simple. In it, of course, we have the user as a relationship to the user model. We also have two additional relations to the company and to the department, which is specific to this project, so we don't need to focus on that, and I will skip it here because in the context of logging users activity, it is not important. Next, we have three simple fields: method, then endpoint in which we will store the API URL that is called, and action. The method and action fields may look similar, but I'm going to discuss the slight difference between them in a moment. The request data and query params are JSON field in which we will store the data that the user sends, and the API request parameters in query params. The description field stores the log identifier, which I will come back to in a moment and explain what it is and how we can use it. Another issue is saving the relationship to the objects to which the request applies. Logs can relate to different objects in different applications and different models. To handle this, I am using generic foreign key, where if we have content type and object ID, we can create a relationship to it in the related object field. It is also important to protect the logs from modification, so in the save method I add a protection that will prevent saving changes and report a validation error in case of changing the object. Finally, let's have a look at the base model class, which is an abstract class and which, as you can see, adds several fields including ID and created at. I mentioned this to show the wider context so that you know where the ID and the created at fields are taken from. If you don't use such inheritance for your models, just add ID and created at in the log model. Okay, I think that's enough for the model. Let's move on to the mixin. Mixin is also quite simple, but has a few interesting things I would like to discuss. The variable action mapping stores a dictionary with translations of the basic CRUD actions into names that are more readable to the ordinary user. I use this dictionary in the getLogAction method, which, as you can see, uses the action attribute, retrieving the corresponding dictionary value. Nothing special here. The action attribute is in every view in the Django REST framework based on the viewset. Another method of our mixin class is the getLogDescription method, which, similarly using a variable stored in the viewset, retrieves a description of the log. I will come back to this in a moment. And the last method is logActivity, to which we pass all the necessary information to record user activity. That is the request object, if it exists, and the data sent by the client or the URL parameters. I retrieve the user ID from the request or mark it as none for requests that do not require a login and in which there is no user passed. Then, if we have an object, I retrieve its ID and from the object's metadata, the model name and the application name. Having the model and ID of the object, I will be able to save this data in the database for linking the log to a specific object. With all the data, we can asynchronously call the Celery task, passing him the necessary data to save the request log. Thanks to the fact that we called the task asynchronously, we do not overload the request itself and saving the log data is done in the background. However, we have here two potential risks which are very unlikely, and even if they occur, their impact on the application is none. First of all, because we perform the action asynchronously, we must be aware that when the task queue is long, logs may not reflect the actual execution time. However, based on observations and my own experience, such situations are extremely rare, especially since we configure the Celery to run several parallel threads handling the tasks. So, even if we have some task that executes for a very long time, logging changes should be handled in another thread of Celery. In general, if you notice that with such a solution, logs starts to be saved with a delay in relation to the actually performed activities, this is a sign that your application needs to a fundamental review and reviewing of code to more efficient one. The second case we could potentially have here is that the task will not execute correctly and the log will not save. I had such a situation when I incorrectly set the length of the method and action fields in the model to 10 characters, and in the views I had actions whose names were longer. Here, however, I was helped by Celery logs whose analysis quickly pointed out the error and I was able to fix it. So it can be said that the log, despite the fact that it was not saved in the database, was saved in the Celery logs. Although, of course, getting it is more difficult in such case. In summary, the important thing is proper monitoring of application performance and database models well thought out. The discussed cases are possible, but their occurrence is very unlikely. Moreover, their occurrence does not affect the operation of the application itself, which is, I think, most important for the user. Okay, let's go further. To call mixin in each request, I override the dispatch method where at the beginning I fetch the request data and query params. The key here is to retrieve the request data and query params before executing the request. If we would do it after calling super, the Django would return us an error. One more note here. When retrieving query params using request get, if there are no parameters, it will return an empty dictionary. Therefore, when saving the data, I check if query params is not an empty dictionary, and if it is, then in the log we write the value none. Finally, after executing the request, I fetch object if there is a getObject method in the given action, then call the log asynchronously to be stored in the database and immediately return the response for the client, so we have no slowdown here. The response time is the same as if we had not logged the user activity. Okay, mixin we have discussed. Now let's see what our tasks look like in which we write the log to the database. For task handling in the project, I use Celery with Redis as in-memory database for task queuing. Into the task, we pass all the data needed to record the user activity. In the task at the beginning, we retrieve the user and the associated company in which he works and the department. As I said, the company and department is the specifics of this project. I won't go into it, so not to obscure the whole picture. What may seem strange at first glance is finding the user using filter and first, instead of the frequently used .get. In this case, I did it intentionally to make the code more readable. .get returns an exception if the object does not exist, while first, in that case, returns none, would eliminate the need to handle user does not exist exception. In the second part of the code, we deal with our object if the object ID, model and application name has been sent and we can identify this object at all. Here I am using so-called values operator introduced in Python 3.8, which when executing a query on the content type model immediately assigns the found value, and if it's not a value equal to none, executes the code for related object using the getObjectForThisType method of the content type object. With this, I simplify the code and get rid of one redundant verification of the existence of the object, similar as we have in getting user above. And finally, we create a database entry and return its ID, which can be further used in the application if we would like to do additional debugging mechanism or integration with other processes. Here, however, we are done and we can move on to the next file. Now I'm going to show how easy it is to add user activity logging to the selected view. Of course, we need to import our mixin, and now we can add it to our view class. And from now on, the view inherits from our mixin and uses the methods we created in it. As I mentioned before, we need to add a dictionary to the view with descriptions for each action we have defined in this view. This is a simple dictionary where the key is the name of the action and the values are the log identifiers that we will send to the front-end application and translate them there. We'll come back to this later and everything will be clear soon. For views, I use a generic view set, and in it we use mixins for the basic CRUD actions of our API endpoint. Since we have list model mixin, we will also have a list action, and for this action we need to add description in log descriptions. Same with retrieve, update, and of course partial update, which is created by update model mixin. We still have create here in this view, but we don't have destroy. However, if we had destroy model mixin, we would need to add the destroy action to the log description dictionary as well. As you see, the implementation is simple. Okay, that's it as far as standard action types are concerned. In log descriptions, we have two more keys: toggle public report and unlock ticket report. These are dedicated actions in this view defined using the action decorator, with which, as we know, we define dedicated endpoints in views, usually for some simple actions on objects. That's why we add these keys to the log description variable. If we didn't do this, then in our activity log mixin, the getLogDescription method would return us a value of log unknown and the action name, instead of description, which we can then handle properly in the front-end application and show users readable and understandable description. Okay, let's move on to the next file. On the backend, we already have a little left to discuss. So far, I have shown how to collect user logs. Now I will show how to display them and show them to authorized users. To start with, let's take a look at settings. For filtering results, I use the Django filters, which is added in the Django applications. This is nothing unusual, I only mention it for a better understanding of the next files I'm going to discuss shortly. In applications, we also have our audit application, and I add it at the very end after adding all the previous applications. As you remember, in a model, we use generic foreign key, which contains a relationship to any model of any applications we have. Just in case, in order to avoid possible troubles with database migrations, I add our audit application at the end after all previous applications to which relations can be stored in the user activity log model. Okay, let's move on. In addition to preventing modification of logs in the model, I'm also adding safeguards against modification of logs in the Django admin panel. In the read-only files variable, I specify all the fields of the user activity log model to protect the admin panel from an accidental or intentional attempt to change a record in the database. In addition, I mark all permissions like add, change, and delete as false, which gives us absolute certainty that from the admin panel the logs cannot be changed. Okay, I think that's enough for admin panel. Now let's move on to the serializers. I use two serializers to present the logs. The first user activity log serializer returns the basic information I display in the log list in the front-end application. Okay, I see a minor mistake here. The description of the method getUserFullName for the key user fullname is written in Polish. Let's correct it to the language more understandable to most programmers. Shame on me. Anyway, we also have user activity log detail serializer, which inherits from user activity log serializer and which contains additional fields not passed in the base serializer. I skip the department name. As I said, this is specific to this project. The important key that I additionally return in the serializer for the log details is request data and even more important content type, which we will cleverly use on the front end in a moment. Since the content type itself will only return the ID, I additionally use the toRepresentation method, which will extend the content type to an object containing the ID, app label, and model. This will come in handy for us in a front-end application. Okay, at the end, let's quickly discuss a few more and obvious things. In the main file of our Django routing, I add the URL of the audit application that contains our user activity log model and views. Here I am using default router, which will automatically generate the appropriate endpoints for us based on user activity log viewset. As you can see, there is nothing extraordinary here, just the standard routing you probably use every day. Finally, the view that handles the display of logs in the front-end application. As you can see here, I have three additional mixins: company filter mixin, department filter mixin, and user filter mixin, which are specific to this project. They do not affect the discussed user activity logging in any way. I do not discuss them to avoid obscuring the picture unnecessarily. What is important here is the use of viewset read-only model viewset, which is an additional third, I think, protection against making changes to the logs. The logs must be secure and cannot be changed. With using the Django filters, I can define in the view the filter set fields variable, where I specify the model fields by which we will be able to filtering data. This is a simple exact filter that we will use to display the logs related to the object. For the functionality of searching for logs of a specific user, we will use search fields pointing to the corresponding fields of the related user model. Here I will enable searching logs by email, first name, and the last name of the user. A quick side note here. I forgot to mention the proper configuration of the Django REST framework. Besides adding Django filters in the Django application section, we still need to indicate in the DRF configuration to use it. In the settings file, in the REST framework configuration for the default filter backends key, we need to specify the list of filters that will be used in the views. By default, I use three main ones: Django filters REST framework Django filter backend, REST framework filters ordering filter, and REST framework filters search filter. In our case, the first and the third filters are important. The ordering filter here I do not use, but in the other views I do. With this configuration, we do not need to add filters in each view, they will be added automatically. Okay, let's go back to the view. As you remember, we have two serializers for the list and for the view details. The corresponding class of serializer to be used is defined in the getSerializer method with a simple condition that checks the called action. And that's all as far as the backend is concerned. Now I will discuss the frontend, where I use an application written in Next.